Okay, so excusing the noise from downstairs, the middle school lunch eaters, I'm just going to continue on from our work today really on logarithms, and just give a few more examples, and then perhaps it'll be easier for you to complete the tasks for prep tonight. So we've looked at the laws of logs, which essentially mean that we can mess around a little bit with numbers and actually make some calculations easier. So if we have just look at one or two more examples, and I'll just sort of talk through it, and then if you're having some issues, then this might help. But if you're not having issues, then you can perhaps fast forward this a little bit. So let's have another look at another example where we have right as a single logarithm, and now that's the task. So let's have a look at, say, log 16 plus 2 log 3. So what we're looking to do here is utilize those log laws. We can unplug this one to get log 3 squared. So that's log 16 plus log 9, and that is log of 16 times 9. We've got our single logarithm now, which is 190 plus 144. Let's double that, log 144. So there's our single logarithm from log 16 plus twice log 3. I'm talking about plugging. This is the plug law, and unplugging it is putting it back up there. So log 3 squared is the same as twice log 3. Sometimes we want to plug, sometimes we want to unplug, sometimes we want to log in, sometimes we want to log out. Hopefully the language is not sending you up the tree. Let's have a look at another one. Log base 2 16 minus twice log 2 3. So in this case, similar question, but now we're looking to, well, I can evaluate that, but before I do so, I'm going to unplug the second. So this will read log base 2 3 squared 9. Now that is equal to log 2, because it's subtraction, log base 2 16 over 9, and that is the as a single logarithm, my result there. Okay, just another type of example, 2 plus log 5. Perhaps I should number these so we know where we're going. 2 plus log base 4 5. Now to write this as a single log, I'm going to have to write 2 as a log. So with base 4, that would be log. So what could I write here so that I end up with the same numerical value as 2? Also, I need to write this number here so that when I raise it to 2, I get this. So that's 16. The value of log 16 base 4 is 2, because I raised 4 to the power of 2 to get 16. Okay. Plus log base 4 5. Now I can bring in log law 1, which is that multiplication law. Log base 4 16 times 5 is 80. So I've written that as a single log. Okay. Okay, let's have a look then at a different type of question, and this will come up in exercise 4N, which I'm going to ask you to also have a look at for homework. And this is how the question looks. If A is equal to log 2 base 5 and B is equal to log 3 base 5, write in terms of A and B. Okay, so the idea of this is to, and these are very popular exam questions, popular among examiners, maybe not students, but these are asked a lot, so we need to get our heads around this. So A is this, B is this, and we need to use our log laws to change these questions around so that we can have log 36 base 5 written in terms of a and b. So we need to get 36 somehow out of 2 and 3. So how can we do that? Can we say that log 36 is equal to, oh, I don't know, is it 2 squared 4 times 3 squared 9? Would that be a fair statement? So log 36 is log 2 squared times 3 squared. This is 4 times 9 is 36. That looks okay. Can I then split up using log law 1? So this is 2 squared plus log 5 3 squared, and then can I bring in my log law to say this is twice log 2 and twice log 3, which is 2a plus 2b. So you can see here what we've done is we've rewritten 36 using 2's and 3's and powers of. We then use log law 1 to split them up, and then we've used the plug law to enable us to write in terms of a and b. Have a look at another example. Log base 5 54. So 54, let's think about that, it's 9 sixes. So can we go 3 squared, is 9 times, that's 18, 27, 3, it might be 27 twos. Might be a better way around that, so 27 times 2. That way we're utilising the 3 and the 2, so we can now split it up like so. I can then plug the left side here, so it's 3 log 3 plus log 2. Now log 3 is b, so that's 3b, and log 2 is a, so I've got 3b plus a for that. If we have a look at another example, log base 5 of 8 root 3. How can I use this? Can I say that that's 8 being 2 cubed, 3 being 3 to the half. So this is 8 root 3, just written another way. I can now split them up, so I've got 2 cubed plus log base 5, 3 to the half. I can now plug it. 3 log 2 plus a half log 3, and that is 3, what's log 2? A, that's a half b. 3a plus 1/2 b. And that's that done. Maybe we should do one more. Log base 5 of 20.25. 20.25 is a fraction, is 81 over 4, so can we look at it that way? 81 over 4. The 81 can be written as 3 to the power of 4, and the 4 is 2 squared. Excuse me. So all I've done so far is I've rewritten 20.25 using fractions. I'm now going to split this up using log law 2. Using subtraction, log base 5 3 to 4 minus log base 5 2 squared. I now use the plug p log 3 minus 2 log 2. I think I just said p log 3 there, it's 4 log 3, obviously I've got this plug in my head. So that is 4a minus 2b. Okay, so there's some examples. You should now be able to have a go at exercise 4M and 4N, and I will put those questions up on the portal. Have fun with that.